looked at it for 30 seconds now. Here. How would you do this? What's your order?
I should just set a timer for 45 minutes and then start lighting sticks.
By burning these sticks, you know, how do you measure for using these sticks as your timer? So no.
You start by burning both sides of one stick, and also burning one side of the other stick. And once the double-ended stick burns up, we'll light the end.
How long did it take for that to burn?
Half an hour.
Half an hour, right?
Yeah, 30 minutes.
So then this one goes, some amount, you don't know how long it's gone, but it's gone 30 minutes worth, right? Oh, I lost my plan, I was doing so well. And then you light this side, right? And so then you have a 30-minute stick burning on both sides for 15 minutes. Anyway. Fire, that's all I know. Don't try this at home. Okay, I want to talk about GUIs for the next couple lectures. That wasn't really a start of a converse with your neighbor comment. So graphical user interfaces we refer to as GUIs. Sometimes we just call them UIs for user interfaces. Hello, would you guys please stop talking? Thank you. So Java has a rich set of tools to create GUIs. It's really going to be our first exposure to a really complicated set of classes. So there's actually, you know, as you get going in more development, you sort of start using these larger toolkits, and part of development is learning how to kind of research these and sort of absorb them all into your brain so you're at least somewhat facile using them. Of course, Google is your friend here. There's no shame in having to look something up, but some sort of bare bones familiarity is important to kind of make progress and not just sort of have to stumble through every step. It's also a new way of thinking about the path of our program execution. So before, programs we've had so far are things like you start at main, it goes down, maybe there's some if statement, and can do two possible things. Maybe there's a loop in here, but there's sort of this flow that we can kind of know exactly what happens. Maybe there's a random number in there, and it might split based on that, so you can't say exactly what's going to happen, but you kind of know possible paths in advance, how these things are going to execute from beginning until end. With our graphical user interface programs, basically have a very simple thing that starts. It loops on its own, checking for events, things that happen like button presses, you know, slider movements, typing in data into a field or something like that. Those generate events, and you have little chunks of code that hang out and respond to those events. And so when you look at these programs, it's actually really hard to kind of figure out what they're supposed to do. We're used to kind of looking here, and there's sort of these layers of abstraction, and it's okay, you know, calculate this, print out some final answer, and you can kind of get an idea just from sort of skimming how main is structured or something. With GUI programs, a lot of stuff is all over the place. There's a little code attached to this button, this code attached to some slider, and you sort of have to work a little harder, I think, to figure out what is even supposed to happen when you run this thing. And of course, when you design it in a different way. Not like, get some data, calculate something, print out the results. It's more like, wait, see if someone types something, and then respond to that. Wait till they push a button and respond to that. You know, you're really kind of, you're thinking at a very small level, but the whole thing together makes a very nice application. So we're going to use what's part of the Java Foundation classes, and in there is the Swing package, and that's basically the GUI building classes that we're going to use. And there's a lot of stuff in there. This is not the only way to build user interfaces. In fact, it's sort of a little more of a basic or older way to do it. So you'll probably run into other versions at some point in your life. Along with things like buttons and menus and all that kind of stuff, there's also a lot of things for internationalization and accessibility and just things to make your applications a little more professional. Now, this is a little bit of a diagram of some of these foundation classes. So it's like, wow, there's a lot to learn in here. And each one of these actually has like a ton of options in it. So, you know, you can spend a lot of time reading through all this. But basically, we have things like checkboxes and menus and buttons and text fields. And notice they're all in this big inheritance tree, right? So of course we have object at the very top. Everything inherits from object. Then we have components and containers. We'll talk about those. And then things sort of related to windows and how they lay out. And then things that actually let you interact with your program, like buttons and text fields and things like that. So there's all these classes, and you're going to use them, some of them directly in your programs, and some of them we're actually going to build our own specializations of those things, make our own kind of button, make our own kind of text field through inheritance, and sort of add again to the capabilities that already exist here. But, you know, this is, so far we've said, like, here's array list, and it has a few methods you should learn. Here's this kind of thing. Here's a few things you should know about it. Now all of a sudden there's like, here's all these things, right? You should learn something about all these things. And so there's this sort of startup cost with these kind of things that's a little bit painful at the beginning because you just don't have any idea what's going on, and it's hard to know where you should start. And it takes some practice to kind of get this absorbed into your way of thinking. So don't panic if at first you're just kind of like, there's all these things I could use and I don't know which one to use. You know, we'll just practice with them and you'll get better at it, okay? Now, this toolkit allows sort of nice applications, you know, better than a console application where it says, please enter a number, colon, and you type in something, and then it says prints out something in response. All of a sudden we have, you know, all these things, and we don't have to, you know, the good thing is we don't have to make the effort to make these things happen, right? They exist for us, and we're going to use them. This thing kind of shows off a lot of the items that are available in the toolkit. So when I say a nice application, this is not a nice application, this is an ugly application, right? So don't fool yourself here. It's very easy to make ugly applications using any toolkit, and this one's no different. There's a whole skill for user interfaces, and typically user interfaces are kind of sort of treated as sort of second-class citizens in development. You know, you write all this cool code that does all this hard computation, and then you just throw this sort of interface on top of it, and people do a bad job with it. And I think there's sort of increasing recognition that how people interact with computers is important, and so as you go through the program, I think you'll see a little more emphasis on building applications that you know, not only let you access the power of what you're trying to write, but also, you know, do so in a fairly nice way. User interface is like a joke. If you have to explain it, it's not that good. So that's the idea that, you know, if you're frustrated because your user keeps doing the wrong thing, and you have all this nice manual explaining how they're supposed to do it, but they still keep not clicking in the wrong order, it's not really their fault, right? It's your fault for not designing that interface in a better fashion. And so anyway, it takes practice and it takes skills. You find specialized classes in your user interface, and it's actually a pretty nice thing to get some skills on. A little cartoon, kind of hard to read, it's a little blurry. To build our new system, we hired an armada of business analysts and architects. Great, and who built the UI? I guess our intern used one of those UI builder tools. So a lot of times, again, people spend all this attention on, you know, underlying code, and then someone just slaps together some UI, and then they wonder why it's sort of a horrible, horrible program. So don't get in that mindset. All right, so let's make a quick GUI program. And I realized I forgot to print out my normal helper code, so I'm going to sit here like, oh. Okay, so we're going to start with what's called the JFrame. The JFrame is basically the window that pops up and has some basic capabilities. And I'm going to call it frame, and we make a new JFrame, and we can give it a title that shows up on the title bar. First, Apple. Okay, doesn't know about JFrame yet? We're going to import JFrame from the Swing library. Once you have a frame, that's not enough to really have anything show up. And so what do I want to do first? Let's take the frame and I'm going to say pack on it. Pack says size yourself to fit all the buttons and text fields and sliders that you know about inside yourself, and sort of make yourself the correct size to manage that. And you can kind of give hints as to how big you want these things to be, but sometimes it's better to let the computer make those decisions. So if you're running this on a phone, maybe it makes it smaller. If it makes, you're running on a big screen, it makes it a little bigger. But pack basically is the thing that kind of arranges all the components. We don't have any components in here yet, but I'm still packing it. And then there is frame set visible to true. And that says basically, show this thing on the screen, and once it's visible, we can actually start interacting with it. Let's see, there's one magic thing I want to do to frame, which says how it closes, and set, let's see, I gotta go cheat now. Set default close operation. All right. Set default, why is it not popping up? Close operation, and I really have to JFrame exit on close. All right. That's the kind of thing I, get going once on one application, I cut and paste it to start off everything else. So that says, when you hit that little close thing on the window, what happens? Well, it actually closes and does not something else. All right, maybe this is enough to run something. Let's see. All right. Here's my application. Yay! I expected that, don't worry. So it has a title, my first app. So it sized itself to be big enough to hold everything, and there's nothing there, so it's basically a zero-sized application, right? Now notice I get all this stuff for free, kind of, right? Like all our stuff, I have a window, I can resize it, which is cool. I can do, it knows how to fill the screen. I know how to minimize myself, and when I click this, it knows how to dive. So by using again a toolkit, I'm not reinventing the wheel. I'm immediately getting something that behaves like an application, like we expect it to behave like, and that's a nice kind of thing. All right, so let's add something in here, and I got it. I can see. Okay, JLabel. Yeah. So I want to add some text here, and that's a JLabel, and I'm going to call that label, and I make a new JLabel, and I add some text. And so this label is sort of hanging out by itself, but also we don't know about label. And instead of kind of importing each one of these things one at a time here, I'm going to import all the things in this swing module package. And so I don't have to keep, every time I add a button or something like that, I don't have to keep adding another specific one. I'm just going to add them all at the beginning. So I have a frame and I have a label, and I need to connect those two together. And so I'm going to add the label to the frame. All right, so when you build these GUIs, there's this whole process that also takes a little while to get used to. And you have to start to learn to think about everything sort of hierarchically. So we have our frame. And then inside the frame, we're going to attach things like a label with some text in it. And we might even have another frame, and then another frame inside that, and then two buttons in there, and so on. So there's all these sort of layers you start building up in order to how to organize things on the screen the way you want them to show up. And we'll talk more about layout next time, but I just want you to start getting the idea that it's not like you just slap a bunch of buttons on there and they magically look good. You have to kind of organize them, and that's sort of actually a very frustrating process, to be honest. It takes a long time to kind of force yourself to add enough detail to make this stuff work out. So if I run this thing now, now we have a label with some text on it, and again, it behaves in a way that kind of is like if I resize it, it tries to stay sort of centered up and down here. And again, you can specify whether you want it to hang out on the top, or on the side, or in the middle. There's all these going to be rules for doing that. But right now, it has some behavior that again is sort of nice for like giving a resize of the window kind of thing. All right, so the main things here are we build a frame. Most things have a frame to them. We're going to add a label. A label is an example of a component or a widget you see referred to, and there's all these different kind of versions of those. We connect these two together by putting the thing on, we add it to the frame, put it inside the frame. Again, there's also some magic that happens here where you say, okay, now frame, resize yourself to be around this thing, and then you say, make it visible. It's very common to forget this part. And if I run it, notice I have just this little tiny window. It didn't try to fit itself around the components, right? It just started off at size 0 and never grew big enough to show the text. And so it can be confusing when that happens to you, but it's still there, right? All right. Questions about that? Can I get the idea here? And again, like, how do you know what to add? Well, you either Google, how do I add text onto a Java frame, or how do I use a JLabel, or whatever level of memory you have about how you do this stuff is what you Google, right? And there's all sorts of advice about how you would find this kind of stuff. And eventually, you just you throw out your labels and buttons, and you're a master at this stuff, and you don't have to look it up anymore. Okay. Let's see where I want to be here. So I've added all this stuff. Okay, let's make this thing more of a class. And we'll talk about why we want to do that in a minute. But right now we're all in this main method here, right? And we have this class structure, and we're not really using it. So instead, I can make my constructor for simple class. And I could move everything from the main to there. That doesn't seem like a very big win at this point, but at least we have a class doing it. And down here, I can make a simple class. Simple class, my app equals new simple class. Don't like that for some reason. Can't resolve to a type. Simple app. That's why it's not called simple class. Simple app. Simple app. Simple app. Okay, so I can run it. It should behave the same. That's fine. We're not really taking advantage of the class structure yet. So for example, there might be methods that want to mess with this frame and turn it on and off, or do things like that. And so maybe I should start moving some of these components of my class up into the instance variables. And down here, I can initialize it, construct it. But now this thing here, I can have another method that does something to it, right? I can interact, I can break my code away from just being like one huge chunk in the constructor or one huge chunk in main and start having methods that interact with it in a little more natural way. Okay, so that wasn't too exciting, but same thing with the label. We can put the label up here. And we'll see in a minute why this might have some use. Private JLabel, label, and we have this. Okay, so different styles, both work. This form here, putting in a class, is going to end up being a little more flexible for us for adding more capabilities to this application. So I'm slowly going to transform this into something that does something a little bit more. Okay, I think this all works still. Okay. Now, again, in this large structure that you get from Swing, there's something called components. Components are the things typically that you see or interact with. So we can have JButtons, and they look like a button. They have text on them that say something, quit, save, etc. When you click it, it makes a little flash kind of thing. It has all these built-in behaviors that are kind of nice. JRadio button. Again, a radio button is one where you have a couple things you want to choose one of. And so if I click here, it turns off that one. And if I click here, it lets you pick one thing at a time, basically. Label we saw has text on it. Text field, you can actually enter values. Like you can edit it, right? The label just displays text, whereas a text field lets the person interact with that text. There's a text area, which is like a whole little editor kind of deal. So if you want more complete information, you use a text editor. There's a combo box, and there's other things too, sliders and kind of things you're used to seeing. Question?
How would this interact if you were like using CSS to design a GUI?
So you're talking like how to use this on an actual like a web page kind of thing? Well, so, to be honest, a lot of front-end web page stuff has moved away from like Java really. It was sort of ironic because Java was first designed really to work in browsers in sort of a safe applet kind of mode. And in some ways other technologies have kind of taken over that. You still can do it. You would basically run your Java file from, there's CSS kind of things, HTML that will run particular scripts that are on your computer, so you can kind of fire off something to run. But in this case, you should package it as an applet, which is a whole sort of self-contained kind of thing, and run that all like that one chunk, basically. So you'd add an applet module into your web page.
Thank you.
Now, containers are sort of less easy to understand exactly what they do because you don't really interact with them in the same way. So containers typically organize the components that you have on your screen. So you might have a panel, and a panel basically is like a small frame without the minimize buttons and things like that. You can add buttons to a panel. You can have a scroll pane that basically, if it doesn't fit on your window, has little scroll bars and stuff. You have a tabbed pane that puts tabs up, and then these layouts that help say whether, if you have 3 buttons, whether they should go across or up and down or in some sort of grid pattern, and again, we'll talk about layouts pretty soon. But these containers basically hold these kind of things, right? They just are organizational tools. If you have a toolbar, that's going to be some sort of panel. You add your buttons on the toolbar, and you add the toolbar to the frame rather than each button individually, kind of thing. So we'll see how this works. All right, so as I was saying, one thing is, in that last program I had, the first post one, didn't have any interaction still, right? It was just a different way of displaying text. So we want to start figuring out how to actually add interaction to our program. And again, you have to kind of think about this differently. We want to respond to user activity. So in Swing, like many user interface programs, we have events. Events are things like a user clicking a button, or changing a checkbox, or typing some text. Or it could also be something like the network saying something has happened, or the system saying something has happened. So it doesn't have to be a user. It can be just some external thing has happened that your program is going to respond to. And Java uses something called listeners to check for events. And so the Swing program is the one that kind of monitors all this mouse movement and all that kind of stuff. It generates events based on what's happening. And then you write code that respond to these events. All right? And the way they do this is not that hard, but it takes a little while to get used to the idea they're using. It has a lot of inheritance and things like that in it. Now, I want to say one thing that's a little bit, I think for the most part, we're not going to have to really touch on, but it may be that some of you on your machines have some minor problems, and I just want to raise this up in case you see it, so you maybe know what's going on. Okay, so when we run a program, it is what's called a process on your computer. And that process has its own space in memory on the computer. And it's only allowed to mess in that memory. So, for example, your program can't write onto the operating system and change some code there or some data there directly. It has to work through the operating system. Your program can't mess with my program. They're in different memory spaces, okay? So that the process basically has its own memory space and has its own time on the central processing unit, on the CPU. So the computer typically runs your process for a little while, and then runs some other stuff for a little while, and then runs yours again for a little while. They take turns, okay? Now, a thread is like a process, but it belongs to a process. And it's a different path of execution of your program. So you might have one part of your program on the CPU doing one thing, and you have a thread that you create that does another thing, and they both can run at the same time, essentially, because your computer can handle multiple threads at the same time. All right, so you hear people talking about parallel programming, things like that. We're talking about usually one way of doing that is with threads. It shares the same memory, so the thread is not like a separate process. It's like a child part that it can still run code, but it doesn't create its own space. Now, a GUI program typically uses threads so it stays responsive. So if I have a program like Word, and I hit, there's hardly anything in Word that takes a lot of time. I don't know.
Excel.
Yeah, let's have Excel program. And you have some huge complicated spreadsheet that takes 5 minutes to figure out the tax returns for the state of Utah or something like that, right? I don't want to have that go, and then my program just totally freezes up. And if I try to resize it, it just like gets all grayed over and doesn't respond to you. You know, it's kind of scary, right? Your program doesn't look like it's working anymore. So typically, GUI programs keep the part that does the calculations on one thread, and then keeps the part that responds to events and so on another thread. And so your program still seems like it's alive because while this thread is calculating all the tax returns, this thread is checking for events and repainting the screen and making it look like it updates. Okay? So all I'm trying to say is that the right way to write a GUI is to have a separate thread that runs the program to make sure that your program doesn't like die when you start doing some calculation. For the most part, we're not going to worry about that. But on some machines, Java complains a lot about you not firing off a new thread to handle the events, and will just like not run your program. So if you're in that case, look at this posted code I said, and we do this sort of crazy stuff. But again, I don't really want to try to explain, but we're creating a new thread, and when that thread runs, it calls the constructor for this StartApplication. All right, so StartApplication is just a method in this class. It's not anything magic. And so all this is saying here is start a new thread and run our program as part of that thread. A lot of times we can just say run our program and it all is cool. But I'm just trying to say, as you get more advanced, or if you happen to have, I think, some particular flavor of Mac OS that doesn't like this, if for whatever reason you're running our sample code and like nothing shows up, try to put this little stuff in here just to fire things off instead of this kind of thing. All right? So just some confusing stuff that we don't want to really get into, but if you run into it, that's the issue.
Do you think this is more likely to happen like 32-bit processors?
I can't remember. Maybe no one's going to have this trouble, you know? And so then just like blank this out of your mind until a year from now when you're taking another class where this gets more important. But I just want you to, and maybe let me know if you have this problem. So I'm curious if it's still like an issue or not, whether there's just some weird thing going on a year and a half ago or not. All right? So you can also just try uncommenting this code and commenting out this code and see what happens and see if you like that or not. So it's really just an aside, just a little warning. Hopefully not a big deal, but I want to take a moment to talk about it. But also, when you write your programs, if you have something that says like a button that says do this action, you should make sure that action is not like 5 minutes long. Otherwise, your program will kind of freeze up and look bad. All right, so yeah, hopefully just ignore this, but keep it in the back of your head if something weird's going on and you're confused by it. All right, so these events are all part, there's a whole complicated interaction between what the operating system lets us do and what your program wants to do. So for example, the operating system knows how to, it's the one that really is looking at our mouse and the trackpad and trying to figure out what should happen when you move the mouse. But the operating system is willing to communicate those things to Java, because Java is very interested in these when it's running a GUI program. And the Java somehow puts them in a form our program can understand. Like that was a click on a button, or that was just a mouse motion in the coordinates of our window kind of thing. And then the Java basically looks for listeners that we've defined and sends the events to those listeners. And that's how we basically get interaction with the program. So let's try to do this in our class. All right, so the first thing is that we're going to implement an interface that knows about these listeners. So that's how Java wants to do this. If we have a button, we're going to want to have that button implement an action listener, it's called. Let me just double check what we're implementing here. Implements action listener. All right, so before we've been extending stuff and inheriting from it, and sometimes your app might inherit from like a JButton, might extend a JButton, it might extend a JFrame or something if you have some new functionality to add to that kind of component. But more typically, your class might just implement the action listener. So the action listener is the thing that's listening for events. And we're saying, I want this thing to participate in that ecosystem of things that listen to for events. All right? So in order to implement something, we have to define the method that it wants defined as part of its contract. And in fact, right here, it's complaining, simple app must implement the inherited abstract method action listener action performed. So there's some method called action performed that these events get sent to, and basically we're going to define how we respond to those events. All right? So we don't actually have anything here yet that generates events that we care about, so we want to sort of, let's make something that can generate events that we want to respond to. So I'm going to make a private JButton, and I'm going to call this quit. So a quit button. And in here, I'm going to create that quit button, JButton, new JButton. And I give it text that I want to display when this thing runs. And I need to add that JButton to the frame, the quit button to the frame. We pack around now the label and the button, and we basically run the thing. So I haven't finished it yet, but I just want to show that I think it's going to at least display at this point. Oh, my label went away. Oh, okay. I need to add another layer to my hierarchy of things here. I make a panel that adds it. So this quit button is kind of taken over the frame, because frames don't know about sort of organizing stuff as well as other things. All right, so I need to make a JPanel, a container that's going to hold the label and the button. Panel equals new JPanel. And now I'm going to add the label and the button to the panel instead of the frame. And then I'm going to add the panel to the frame. All right, so I'm now taking our simple little label and adding to a frame, and I've said, let's make a panel. And to the panel, we're going to have our label, and we're going to have our button. So these two get added to this thing, and then this thing gets added to the frame. All right? And it gets complicated pretty fast, right? You have to start remembering which thing you belong to and where it is on screen and all that stuff. Let's see if I did this right. Okay. Phew. So now notice it laid it out. The default layout for these things is that they just sort of go from left to right in the order that you add them. So that's why we have first the label, and then we have the quit button here. And I can click that. And notice it has, like, you know, nice behaviors. Again, I didn't have to like think hard about how to make that flash or anything like that. It's just there. And again, these are all things. All these things have millions of options to tell you how it behaves. You know, what color should it flash? What color should this thing be? What color should the letters be? Should it be a raised boundary? How thick should the boundary be? Should it have, you know, should it be a sunken look or a raised look? And so there's like so many things you can kind of play around with these things. So they want to give you a lot of control over what this thing looks like, right? All right, so again, we have our frame, and we have our label and our quit button. We add those two things to a panel. The panel we add to the frame. So we have this hierarchy, and you have to kind of keep all that track in your head. Now there's something different here. Notice I made the label and the quit button instance variables, but I made the panel just be a little local variable here. So that's sort of a funny thing. I didn't really do it for any super important reason, but basically, I'm not expecting to have to manipulate this panel from other methods of my code. And so I can just make this a little local creation here. But when I add it to the frame remembers that reference to the panel. So even though we lose the reference to the name panel to this object here, the frame knows about the panel and can do things to it, like display it. We just don't have named access to it once we leave this constructor here. So things that you think you want to use elsewhere in the class, you should probably make instance variables. But things that are just little organizational things that help structure what the program looks like, typically are going to be just local variables in the method you build it in. And they don't like they go away when you leave the method, but the name goes away. You can't access it directly anymore. You can still access it, like with frame, I think there's a get components method. And so I can get like a list of all the components that are in the frame. And so I could get to that panel sort of indirectly by knowing it's the first component in the frame or something like that. But I lose that panel name reference because I don't care about it. I just want to build a panel. All right. So again, there's all these sort of little decisions you can make when you're making these things. And you should kind of think about whether, again, you want to maintain sort of global access in the class to something, or whether you want to just create it and have it show up on the screen and not really worry about it anymore. Okay, so we have our button, and it doesn't do anything. And so the question is now, how do we tie this into like a click event and make it actually do something? And the way we do that is we implement this thing that we've promised to implement through this interface, this ActionListener interface that we are just declaring that we're going to implement. And again, it wants us to make this thing called action performed. And let me make one of these. Okay, so it's a method, it's a public void action performed, and it takes in an action event E is typically what you see. Is that right? Action event? Let me look at this. Action performed, public void action event E. Should be happy. I got import. Something new for that one. Okay. In this action event, so basically any event that happens gets sent to this listener, and then it's up to us to decide what to do about it. So right now, the only thing that can make an action is the quit button. And I can say dispose. I want to dispose the frame, but basically kill the pro. That's one way to kill the GUI. Okay. So when I hit quit, an action, when I click the button, it generates an event. The event is sent to all the listeners in the whole program, and they kind of decide if that's something they want to deal with or not. And right now, the only thing we want to do is quit when we hit quit, so I'm just going to put that in there. So if I run this, and I hit quit, oh wait, did it do anything? Ah, I know why. I forgot something here. So when I make my button, I have to say that there is an action listener that belongs to that button. So I'm going to say add action listener. So I'm saying what object is the thing that has this listener? All right. Now, in this case, we have this class, simple app. It has this action listener, action performed listener. What is the object that has the listener at this point? This is a big question, right? And it's kind of confusing to me, so we have to find this method for a class. What class, first of all, tell me, what class has the action listener?
Oh, simple app.
Simple app has the action listener. Do we have an instance of simple app anywhere? So what code are we in here? The constructor for what? And so what does that make an instance? Yes, that's what the constructor does. It makes an instance of simple app, right? So in the constructor, we're constructing a simple app object. That object has the action listener. What is the name of this object, this simple app object? Down here, it's called my app, right? What's it called in the constructor? This. This is the keyword that refers to the object that called this method. The method is the constructor. So we're going to say this here. All right. Now it seems kind of weird. We have this button, and in some ways you want the button to be listening to this thing, but it's not. It's the application that's listening for events. Okay. And sometimes that's not true. Sometimes we're going to make like a new kind of button that has its own action listener or something like that. But in this case, this refers to the simple app object that's being constructed. Simple app is the thing that has the action performed method that implements the action listener interface. And so we are telling this button to use this action listener that was defined in this class. All right? If I run it now, quit, yay. Okay, so we have an action, we have an interactive program now, right? All right, so let's add another button. Private J button beep. And I'm going to make that beep button and I'm going to tell it to use the same action listener as the quit button. Now that's a little bit of a problem because if I run my code right now, I didn't add beep to the panel. See, there's a lot of stuff to keep track of when you do this. So don't be surprised when like you're doing your own code and like it doesn't show up or something. Is this something you forgot? Don't panic, right? Like there's like all these steps you have to kind of remember. Add the action, make the button, add the action listener, add the beep. All right, so first post quit, we know quit works. If you hit beep, it still quits, right? And that's because it generated an event. The event came down here and it says, when you get an event, kill off the frame. So we're not doing anything different. So now we need to add some stuff. If E, the event that was sent to this thing here, you can actually say get the component that generated that action, right? So this is basically saying where does this event come from? And if it's equal to the quit button, then I want to dispose of the frame. If get source equals beep. So notice this is why I wanted to put these components as private instance variables of the class so I could access them easily down here in the listener, right? I can compare it to what it is.
I'm just curious about the equals versus dot equals.
So dot equals to say if the thing has the same values inside it, then compare, say they're equals. If it is the beep or quit button. So in this case, the source it gets really is the quit button. And I mean, maybe you want to say like, hey, if your name is quit and you're ahead of stuff, then you should also quit. You know, use dot equals or something. But here we're trying to find out if it really is that component we made. It's the quit one. If it's beep, what can we do? I'm going to just do something that makes a beep that I randomly found. Okay, so now if I volume, oops, and run the code. It's funny, I keep wanting to hit quit. Like, does quit still work? It's going to, you know, I won't let's get very far. So I hit beep. Oh, that is so quiet. Okay. Shh. That's not as impressive as I wanted it to be.
Probably just like all the way.
Let's add one more button. Hide. And at this point, we're hopefully getting the sort of process of adding buttons down a little better, and I'm not going to forget the step. Add it to the panel. Add it to the listener. That was a little awkward. Now, just because I'm a GUI program means doesn't mean I can't mess around with the console anymore. We're reluctant to give that up because we love it so much. So I'm just going to print something out and say, hi. So now we're getting quite the collection of things here. We're going to really need to start looking at these layout kind of things or adding more panels so it's not, just like my weird program that is 20 pixels high and 800 pixels across or something like that. But if I say hi, you can see the bottom, it says hi. All right, so I think that's enough for now. Here, Chesterman got them. I have a runestone out talking about inheritance things and about 2D arrays because we're using 2D arrays in the GUI program we're going to release on Monday. So it's not due until Wednesday, but I want you to get started on that.
Are you posting A9 tonight?
I'm going to do it Monday. We need one more lecture to figure out how to do it.
Oh, so we're getting A9 on Monday.
So work on the runestone. Yeah.
When is A9 due?
Let me do the